So for problem number 6, just drawing the scatter plot, we drew a line through there. I mean, it says what relationship, if any, that's linear. Okay, it appears linear. And then draw a line of fit. Again, trend line for the scatter plot and write the slope-intercept form. Well, we have to come up with 2 points on the line, and I'm going to pick 10 and 20 here. So we're going to go 10 and 20. So we have the coordinates 10, comma, let's say 36, and we have 20, comma, I don't know, 49. Okay. And if I want to come up with the equation of the trend line, I need to make sure I come up with the slope first. 49 minus 36 over 20 minus 10. I like 10 because when dividing by 10, it means I move the decimal over 1. So I have 13 over 10, which means I have 1.3. So I like a decimal like that, 1.3. And then my y-intercept looks to be right about 25. So if the y-intercept is about 25, that means our trend line would be y equals the slope times x plus our y-intercept. Now, that's our equation, and then we're going to make a prediction here. So, predicting the maximum longevity for an animal with an average longevity of 33 years. So, looking here, the number of years, that's our x, the average number of years. So, the average is our x. What are we doing here? I didn't even read the problem. The table shows the average and maximum longevity of various animals in captivity. Okay, I got it. So the average longevity is, if the average longevity is 12 years, then the maximum would be 47 for various animals. So for one animal, their average is 12, maximum 47. Another animal, average 25, maximum 50. So one would assume that the higher the average lifespan for a particular animal, the higher the maximum lifespan would be. So that would make sense that it would be a linear. But the average longevity, that's our x. Remember, so the x is the average and the y is our maximum. Predict the maximum. So basically what we're doing here is we're trying to figure out what's the y value when the x value is 33. So using our trend line equation, we'll plug in 33 in for the x plus 25. And so if we multiply 1.3 times 33, we get 42.9, and we add 25 to that, and we get 67.9. So therefore about 68 years. So we might want to make sure we keep that 67.9 there to show that we plug 33 into our trend line equation, and then we end up getting about 68 years when we plug that in. So that's what we would expect the maximum lifespan to be. And if we look at 33 over here, it's close to about 68 years right there. So it checks out.